In my previous video, I discussed the single step binomial option pricing model. Now I am going to discuss application of two-step binomial option pricing model. At the same time, use of Excel for option valuation. How Excel sheet can be used to determine the value of the option, that will also be discussed. Okay. Now, this is a problem. It is better to discuss through a problem. The problem is this: the stock price starts at rupees 20 and in each 2 times step may go up by 10% or down by 10%. Suppose that each time step is 3 months long and the risk-free interest rate is 12% per annum. Determine the value of call option where strike price or exercise price is rupees 21. That means initial price is rupees 20 and it is a two steps model. The length of each step is 3 months long and the share price may go up by 10% or down by 10%, and risk-free interest rate is 20% per annum. Strike price 21. This is rupees 21. This is the problem. Here it is assumed that the interest rate is continuous compounding. It is better first to see the entire steps of the binomial option pricing model. This is the picture where two steps are being shown, and then we'll back to this single part. How? That I'm going to discuss. This is the initial price, rupees 20, that means starting price, and the price may go up by 10% and may go down by 10%. If it is up by 10%, that means 20 plus to 22%. At the end of this period, that means 3 months, the up price will be this and the down price will be this. That means if the price decreases by 10%, then the decreased price will be this. This is first step. This is a two-step binomial option pricing model. That's why after second step, the price will be this, when it will be increased. This is 22 plus 10%, 2.20. That's why 24.2. Up price is this and the down price will be this. If 10% is less deducted, then the price will be this. Similarly, considering this price, if 10 price is increased, then it will be 19.8, because 18 plus 10%, 1.8 is 19.8. That is the up price after this second step, that is second 3 months. And if the price is decreased or down, then the down price will be this minus 10 price. That is 18 minus 1.8, this 60.2. And the strike price or exercise price is given rupees 21. This is the whole picture, and this period is 3 months. In the problem it is given 3 months long. I will discuss this picture later on, it will be better. First see the overall picture, then we will discuss how we will apply to find out the initial option price. That means the option price at this point. Now see what will be the call option value at this point. At this point means D. After two steps, what will be the call option value? Strike price or exercise price 21 and this price is 24. The difference is the call option value. That I have discussed already in my previous video. If you have any doubt, you can check and see that video. Then you will understand it clearly. And what will be the call option value at this point? Strike price is this and the share price is 19.8, which is below the strike price or exercise price. That's why the call option value will be 0 at this point. And what will the call option value at this point? Again, this 16.2, the share price is below the strike price 21. That's why call option value at the point F will be 0.0. The call option value of the share price is 0 at this point. So first of all, you have to find out the call option value at the end of the two steps in this way. That is, at this point the call option value is 3.2. At this point the call option value is 0.0, and at this point the call option value is 0.0. In my previous video I discussed how to find out the single step binomial option pricing model. Now you can solve this problem step by step. First, considering this call option value, call option value this and this, you can find out the option value at this point by applying the previous method. Similarly, by applying the call option value at this point and at this point, you may consider this as single step. You can find out the call option value at this point. How we find out that I discuss, and we will get, when you will get the call option value at this point and at this point, then it will be easy to find out the call option value at this point. So I am taking this part only. By this part only, how we will find out the call option value at this point. For this, I am going to the previous slide. This is the 22 rupees. This is the D point, B, D and E. You see B, D and E. I am taking this part only. Here 22, 24.2 that I have written here. To show the entire picture, actually I have taken this slide. Okay, now this is the end price after second step, and this is the end price, down price. This is the up price, this is the down price, and this is the call option value at this point, and this is the call option value at this point, and you have to find out the option value at this point. But we know how to find out the option value at this point by using the formula that I have discussed in my previous video, that I have used here. So what will be, this is the formula. This is the formula for risk neutral probability. The formula is, the probability will be e to the power RT. R is the interest rate, T is the time period, minus D divided by U minus D. I use the up factor and D is the down factor. As 10% is the increased price, that's why the up factor will be 1 plus 0.1. 10% is 0.1, that's why 1.1. And the down factor will be 1 minus 0.1, that's why 0.9. Interest rate per annum is 0.12, and T, the period, that is B to D, the length of this period B to D is 3 months, that is 1/4 year. As this is the per annum, that's why you also have to convert the 3 months to year, that's why 0.25. If you put the value of this R, T, D on this, then you will get the risk neutral probability P. You have to find out this first, that I have discussed in my previous video. Again I am computing this. The P is equal to e to the power 0.12, the value of R, T is 0.25, it is shown here, minus 0.9 D, down factor, and the up factor is 1.1, and U minus D, and if you calculate this, then you will get this probability. Okay, now with the help of this, I have to find out the option value at this point B. How will find out this? This is the formula for single step binomial option pricing model to find out the option value, which I have already discussed in my previous video. But this is the formula. If you apply this formula, then you will get the option value that I have done here. Option value at node B, option value at node B is equal to F. The formula is e to the power minus RT. Sorry, this will be e to the power minus RT. This will be minus 0.12 into 0.25. This is minus, actually, some minus 0.12 and 0.65 P. The value of probability I have already calculated here, that is 0.6523 into 3.2 is the call option value. AFU means this is the AFU, call option value at upper price of this share, that's why AFU. And here also in this picture also it is shown the call option value at the upper price is 3.2. So 3.2 plus 1 minus P. 1 minus P, the formula is 1 minus P. 1 minus this, you will get this value. You can check it. And down call option value, that is, this is the down call option value AFD is 0. That's why I have put here 0. If you calculate this, then you will get the value 2.0257. That means the call option value at this point is 2.0257. Okay. Now again I am going to the detail formula, detail structure. This is the 2.0257. I have just now calculated it. With the help of same formula, if you use this upper value 0.0 and down value 0, then you will get the call option value here, that will be 0.0. As you can check it, if you use this value, this is 0, this is 0. If you multiply 0 and whatever the value of probability value is given, then the entire value F will be 0. That's why the down value, call option value at this point C will be 0. In this way you can find out the call option value at the point B and C. That is after first step, 3 months or 3 months long. The call option value will be this, and the point at the point the call option value will be this. Now you know the call option value at this point and at this point, and P will remain same, is a risk neutral probability for the same problem. That's why you can again use the previous formula, this formula, to find out the value at this point. That formula I have again written here, e to the power minus RT P into FU minus P into T. FU means this FU for this tree, for this part, FU will be this and FD will be this. If you put this formula, e to the power minus RT, e to the power minus 0.2 into 0.25, T is 0.25, and this is the probability, and the call option value is this. That's the call option value is written here, 2.0257, plus this is 1 minus P, and FD, the call option value at the down price is 0, and if you calculate, this will be the call option value. You will get this call option. This is the answer. In this way, you can find out the call option value of 2 steps binomial model. So again, I am repeating in brief how you have solved this problem. First, you will draw the structure. First, entire structure you will draw. This is the tree, and put the prices of the shares at different point. Initial price is 20, 10% increase in price, that's why it is 22. 10% down price, decrease in price, that's why 18. And this is the first step. For second step, you write the price of the shares. If you increase 10% to this, that means 22 plus 10% means 24.2. And if you decrease 10% to the second step, the price will be this. Similarly, for this price, increased price will be this. You can add 10% and you will see the up price is this and the down price is this. After putting the values of the share at different points of your nodes of the tree of different steps or 2 steps, you calculate the call option value. Start from the end of the tree, that means from the last point. This is the process. This is the strike price. Strike price and exercise price is same. We know this is the strike price 21 and this is the share price. That's why call option value will be this. Why this? That I've already discussed in the previous value. 24.2 minus 21. This is the call option value. As this is the higher and strike price is lower, then it will be applied and the value will be this. What is the call option value at this point? As this value is lower than strike price, that's why call option value is 0. In this way, you will find out the call option value of the last end point. With the help of this value, by applying the formula, you will first calculate the risk neutral probability. The formula I have already discussed in my previous video. Again, I have discussed. This is the factor, 10% increase. That's why this is the down factor, and this is the value of R, and this is T is the period. If you put this is the probability, the risk neutral probability, and if you put this probability in this formula and the call option value, then you will get the call option value at this point. In this similar process, you can find out the call option values at this point. With the help of this call option value, again you can find out the call option at the beginning. Our purpose is to find out the call option value at the starting point when you are interested to deal the call option. That's why you are interested to know the value. Then again you will apply this formula. The probability will be same as this is the same problem. That's why it will not differ, and putting the value of the call options, you can find out the call option value at this point. In this way, you can find out the call option value for 2-step binomial model. The same problem again, it has been shown more clearly. To this I am not going to repeat it again. Just simply the entire symbols are used, because next step we will discuss how you can calculate the call option value for 2 steps binomial option pricing model directly by using a single formula. That's why just I have used the notations in this way. FUU means this is the final call option value. After 2, this is the after 1 step call option value, and this is after 2 steps. That's why FUU, and this is the value. How this has come, that I have discussed. This strike price, same problem I have again shown. Just another term I have used this formula to use in the formula FEU, FUD, FDD. DD means down, double down, and FD means after single step the down call option value. And you can use the formula directly, then you will get the call option value. How you will use that I will discuss in the next slide. First, this is the generality for two steps, and these are the different equations. For this is the first equation, fu to find out fu. How you will find out fu? E to the power minus RT. P into P is the probability. How probability will be calculated, that I have already discussed this formula. You have to use it. You have to use this formula to find out the P. P FU, with the help of this plus 1 minus P FUD, you can find out FU. That I have already just now discussed in the previous slide. How you have calculated with this formula. That is done here. It is a generalized form only. This is two-step generalized binomial option pricing model, and with the help of this formula you can find out the option value directly. Now FD, how will find out the down value? For that, this is the formula, e to the power minus RT. FUD, FUD is the offer call option value plus 1 minus P FDD. This is the down price. In this way you can find out the UT. That means you can find out the FU, the call option value at its upper point, and call option value at this is the general formula. If you put the formula of FU and FD to this F, this is the F for general formula. F is equal to E to the minus P into F of U plus 1 minus P F of D. If you put the value of F of U and F of D and simplify it, some mathematical derivation is required. Actually, I am not going to discuss the detailed simplifications. Just directly after simplification you will get this formula. This is the formula for finding out the call option value for two-step binomial model directly. Directly means you can use straight away this formula to find out the call option value at this point. For this, what is required to be computed? You have to compute the P, how it is calculated, that I have already discussed, and you put the values directly. P square FU means this call option value of this plus 2 into P plus 1 minus P FUD means this, and plus 1 minus P square FDD. If you put on this value, then you can find out the call option value directly. I will show through different problem. Okay, now I am going to discuss the put option value. Previously I discussed the call option value. Now put option value. This is the problem. 2-year European 2-year. Your period is year. Consider a 2-year European put with the strike price 52 and stock whose current price is rupees 50. We suppose that there are 2 time steps 1 year, and each time steps the stock price either moves up by 20%. Previously it was 10%. In this case it is 20%, or move down 20%. Okay, a risk neutral interest rate is 5%, and it is assumed that the case of continuous compounding. You have to find out the put option value using these 2 steps binomial option pricing model. How you have done this? First, see the picture. This is the picture. You have drawn initial price is 50, 20% increase means 60, again 20% is 72, and from this point decrease in 20% means minus 12, that's why 48. In this case again 40, if it is decreased by 20% then 40, and increase by 20% then 48, and decrease by 20, that's why the price is 32. So as I have already discussed, you have to find out the put option value at the end point, of the share price. If the share price is 72, the strike price is 52. What is the put option value? In the case of put option value, as the price is more than the strike price, that's why put option value is 0. But in this case, as the share price is less than strike price means 52, that's why the put option value is 4. 52 minus 48. That I have discussed why. If you have any doubt, then you can check it from my previous video. So what will be the value at this point? Put option value 32, 48 minus 32. 48 minus 32 means how much? 40. Where is the value? Strike price is 52. 52 minus 32. This is the put option value is rupees 20. In this way, you can find out the put option value at the end for all situations. FU is 0, FUD is 4, and FDD is equal to 20. Now with the help of this, if you interested to solve stepwise, then you can put the value in this formula and you can find out the value f of u. F of u will be 1.4147. I have already discussed what is the value of p. First you have to find out the value of p with the help of all these values, and the value of p is 0.6282. You can check it. The value of risk neutral probability is this. That's why this is e to the power minus, interest rate is 5%, 5%, that's why 0.05. R here, that's why I have not changed it. 0.05 into 1. Period is 1. And this is the probability. This is the probability into FU. This is the formula FU. FU is 0. Put option value is 0. That's why 0 plus 1 minus P is this, into down is 48. In this way you can find out the value, this 1.41. If you apply this same formula at this point, here I have applied it, you can check it. The put option value will be this. How? This is the formula, this are T. The P value remains same if you calculate through the formula, and this is the up. If FUD is 4, that's why 4 plus 1 minus P into FDD is 20. 9 point, this is the option value at this point. Now again, if you apply in the same way for single step, then you can get this formula. You can check it. Okay. You can now put option value. How you can use direct formula, that is the step by step formula I have shown you. Now I am showing you how to use the direct formula. What is the direct formula? The direct formula is this. You note down it and check it. F is equal to e to the power minus RT, F is equal to e to the power minus 2RT, P square FEQ 2 into P. This is the entire formula. Okay. Now I am using the direct formula to find out the value of the put option. I am dealing with the put option. If you put all these values, minus 2 into R is 5%, 5%, T is 1, and P value is this, P square. That's why this FEU 0, and if it is call option, then the value will be different. And plus 2 into P, probability P is this, into 1 minus P into FUD is equal to 4. You can check it, FUD is 4. That's why FUD is equal to 4 plus 1 minus P square into FDD is 20. And if you compute, then you will get the value 4.1923. What? 4.1923. We have calculated. If you do it in stepwise, then also the same value will come. Achha, for calculation, I have already mentioned that Excel sheet you can use to avoid the lengthy computations. One time if you develop the formula in the Excel sheet, then just put the value and you can get the result. You see how it is done. This is the Excel sheet. Now I am going to the Excel sheet. This is the Excel sheet. U is 20%, that is 1.2. D is 0.8, the decreasing factor. Time period is 1 year, that's why 1. Rate of interest is 0.05. FU is 0. Just now I have shown you FUD is equal to 4 and FDD is equal to 20. All these are the inputs, and if you put the, and this is the probability formula, this is the probability formula, how to find out the risk neutral probability. Just you put the formula here, exponential C6 into C5, C6, this is C6. I think you have the basic knowledge of Excel. C6 is this in the probability, C6 into C5. This is the formula I have written, and after that you will get, this is the risk neutral probability. And if you put, this is the formula for final option value. You can do it slowly, then you can check it. The formula is exponential minus 2RT. You see the formula, you have to back it, only then you can see. The formula is e to the power minus 2RT. E to the power, E means exponential. This is the Excel formula, minus 2R. R is written C6. C6. R is 6. You see, this is the rate of interest. C6. And C5. T is the C5. R is C5. This is pure. In this way, the entire formula is written. You will check slowly, and you can also develop by yourself. And this is the value which we have computed manually also. You can check it. You can note down it. 4.192654. And if you do it step by step, then see, this is the formula for first step. FU formula is this. The formula is written in the Excel sheet, and this is the formula written for Excel say FD, that means put option value at down price, and then by using that, it is the put option value at the starting point. The value is same, but this is two methods. This is used directly in a single step, and this is done step by step. First step, then initial step, in this way. So in this way you can use the Excel sheet also. Now if you change the value instantly, you need not to compute it different times. Suppose the U is the factor is 30%. Say, I don't know. You just change the value 1.3. If you change instantly, sorry, 1.3, not 1.3. If you put the value 1.3, then the entire value will be changed instantly. That I think you don't know. The entire value will be this. That is the advantage for Excel sheet. By using Excel sheet, the computation time will be less. So in this way you can also solve. So now again I'm going back. So by using Excel sheet also you can compute the call option or put option value directly with the help of the formula. Formula is same, only this value will change for call option and put option. In the case of call option, this value will be different if you do FDD, or in the different, but P value will be different. If you put this value, then directly you can get the call option value. Okay. Now, and this is the step-by-step formula. This is all about of your binomial, two steps binomial option pricing model. So again, I'm just telling you in brief what we have done today. Step by step we have solved the problem in two steps, or you can use a direct formula to get the call option or put option price. You can also use the Excel sheet to compute the value directly. That is all about the discussion. This is a message. You can put your comments, queries, and it will be appreciated. And if you want to discuss, then you can write a mail to me, and definitely I will give suitable time. And for better knowledge, it is better you consult this book. I have written the book for help, and thank you. This is all about